What's in My Honey is a citizen science project based at the Australian National University. This project is for beekeepers who are curious about what plants their bees are pollinating. In the last video instalment, we showed you how to extract pollen from your honey at home.
Now, we're going to show you how we process the samples that you sent back to us. The first step was to allow the pollen to settle at the bottom of the tube. To do this quickly, we put the samples in a machine called a centrifuge. A centrifuge spins material very quickly. As pollen grains have a greater density than water, as they spin, the pollen will collect at the bottom of the tube with a layer of water on top. After 3 minutes, the pollen will have gathered at the bottom of the tube. The pollen grains are coated in these things called polysaccharides, which are carbohydrates often found in food. These polysaccharides conceal the grains, so we need to remove them in order to identify the pollen. You can imagine it like fruit wrapped in our foil. You need to remove the foil to identify what fruit it is. To remove the polysaccharides, we need to add a really strong acid. But this acid is highly reactive with water, so we have to make sure all of the water is gone before we use the acid. We do this by replacing the water with glacial acetic acid, and we do this by adding it to all the samples.
Once all the water was removed, we added the really strong acid and placed the samples in a hot water bath. After 5 minutes, we removed the samples from the bath and disposed of the excess acid. Now that the samples are free of polysaccharides, we need to get the samples in a state where we can look at them. This involved washing the samples in glacial acetic acid again to remove the strong acid, so we could then wash the samples in water. After repeating this process several times to make sure the samples were free of acid, which involved many spins in the centrifuge, we can finally look at the pollen. To prepare the samples for the microscope, we mounted the pollen onto glass slides with a drop of glycerol. We sealed the pollen onto the slide by adding a glass cover and coating the border with nail polish. This prevents the pollen from leaking. We then looked at the pollen under a microscope, where we identified and photographed the pollen. Here are some images we took of some of the samples. These are myrtaceae grains, most likely eucalyptus. As the most common and widespread trees in Australia, we see a lot of eucalyptus pollen. Here is an image of a dandelion and Scotch thistle pollen grain. We would like to thank you for collaborating with us on this project, or if you haven't already, contact one of us to get involved.